Hi, Year 7. So here we are. This is lesson 11 and we are going to talk about physical and chemical changes. So let's have a look at our learning outcomes. We are going to state that a chemical reaction is irreversible. So we're going to look at the words reversible and irreversible and see what they mean. And then once we've done that, we're going to start to describe the changes that happen during a chemical reaction. Start to identify the things that tell us that a chemical reaction is happening. Okay, so let's start off with these two words, reversible and irreversible. And we're going to start off first with reversible. So think about when you're in a car, okay? When you reverse, you go backwards. So if you drive in a car and you drive, say, 20 meters down the road, and then you put the car in reverse, it can go backwards. You can go back to where you came from. And that's basically what the word reversible means. If we think of water and ice, for an example, if you put water in the freezer, it will turn into ice. But if you take it out of the freezer and put it in somewhere, a windowsill or something where it's warm, then the ice will melt and you will end up with water again. So you can go back to the start. Okay, and that's what reversible means. If something is reversible, if a change is reversible, then it can change back again. So ice can change into water and water can change into ice. Okay, so that's reversible. So obviously irreversible means that we can't go back to the start, but let's just have a look at that in a little bit more detail. So this time we're still in the kitchen and we have got milk and flour and eggs, and we're going to mix them together in a bowl. We're going to put them in a frying pan and we are going to make pancakes. Okay, so here's the question. You've made pancakes in the kitchen. I want the milk out of the pancake, please. Can you do that? Can you give me the milk back? Well, no, you can't, can you? You can't get the milk out of a pancake. It's just never going to work. Now, that is an irreversible change. What you've done in that frying pan is actually you've done a chemical reaction. You have made the component parts of the flour, the eggs and the milk react together to make a new substance, to make a compound, essentially, called pancake. So you can't change it back. So it's irreversible. Now, physical changes are reversible, so things like melting and evaporating, those are reversible. They can go back the other way because we can freeze and we can condense. But chemical reactions are irreversible. We can't make what we had at the beginning again. And that's because something new has formed. Remember, we talked about this in the last couple of lessons. Chemical reactions are when we form a new product, a new substance is formed. So they are irreversible. We can't go backwards. We can't go back to the start. Now, chemical reactions are irreversible, but sometimes it's a little bit tricky hard to decide whether something's irreversible. So we've got other signs, other really easy signs that tell you that a chemical reaction is happening. And we're going to look at those next. So the first one is a colour change. Okay, so copper, you know copper, you've seen pictures of copper this half term. Copper is a reddy brown metal. It's the sort of stuff that you see all around the house whenever you have water pipes and things. Those are always copper pipes. Now, this is the Statue of Liberty, and she's made of copper, but you can see she's not reddy brown. And that's because the copper has reacted with chemicals in the air. And it's reacted with chemicals in the air to form a couple of things, including copper carbonate. Okay, and copper carbonate is this green colour. Okay, so a sign that a chemical reaction is happening is we have a colour change. Another sign that a chemical reaction is happening is we see bubbles. So if you look at this experiment, this is baking soda, and the girls and the boys there are adding vinegar to the baking soda. When you add vinegar to baking soda, there's a chemical reaction, and one of the products that's formed is carbon dioxide. Carbon dioxide is a gas, and when gas is formed, we see bubbles. So sign that a chemical reaction happening, number 2, bubbles. Okay, the third sign is called a precipitate. Okay, it's a posh word, but don't worry about it. What it basically means is if you add 2 liquids together, so 2 clear liquids, like the one in this pipette here, and the one in the conical flask, if you add those two clear liquids together, you get a powder. And depending on the chemical reaction, that powder can be yellow or white or brown. But the point is that if you get this powder or precipitate in the bottom of the conical flask, that tells you that a chemical reaction has happened. So a precipitate, powder in the bottom of two solutions, is a sign that a chemical reaction has happened. Okay, this one, not so pleasant. Smells, a change of smell is a sign that a chemical reaction So when you burn something, you can smell that. You can smell things burning, can't you? And that tells you that there's a chemical reaction happening. The same thing is when things are rotting, when a fruit is rotting, it doesn't smell very nice, does it? And it doesn't smell very nice because there's a chemical reaction happening, and that chemical reaction is forming sort of chemicals that don't smell so good. So a smell is a sign that a chemical reaction is happening. The last one, which I haven't got a slide for, is a change in temperature. So if you put two chemicals in a test tube and the test tube starts to feel really warm, that's a sign a chemical reaction has happened. And it can go the other way as well. Sometimes you can put two chemicals in a test tube and the test tube will suddenly start to feel really, really cold. And that's the sign that a chemical reaction has happened. So if there's a change in temperature, it's a sign the chemical reaction has happened. Okay, so I've talked about the sort of 5 signs that chemical reactions are happening, and we've talked about reversible and irreversible. I'm just going to play this video now for you guys. Okay, I'm going to stay here, okay, but I'm going to let the guy on the video talk to you for a couple of minutes. So here we go, physical and chemical changes.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about physical and chemical changes. Physical changes are changes in appearance only. A new substance is not created, and chemical bonds are not formed or broken. For example, take this stack of paper and wadding it up into smaller pieces is a physical change. It still has the same properties as the original paper. Cutting someone's hair is a physical change because the hair has the same properties as the original hair. Phase changes are physical changes. When ice goes from a solid to a liquid to a gas and then back, those are physical changes. Most mixtures are physical changes. For example, mixing salt and water together is a physical change because the salt and water can be separated out later. Chemical changes, on the other hand, create a new substance. It involves breaking or making chemical bonds between atoms. Chemical changes leave behind clues or indicators. Here are 5 indicators of a chemical change. First, if you see burning or fire, you have a chemical change. Second, a temperature change without heating or cooling is an indicator of a chemical change. Third, an explosion is an indicator of a chemical change, and they're pretty fun. A change in color is a chemical change. A change in odor can be a clue that a chemical change has occurred. And anytime when you mix items and you see bubbles or it fizzes, you have a chemical change. Thanks for watching Physical and Chemical Changes. Moo Moo Math and Science uploads a new math and science video every day.
Okay, so let's put that into practice here. I'm going to play this video and you are going to tell me whether you think it's a physical or a chemical change. I'm going to play it twice. I'm going to play it once through, just letting you decide, and then I'm going to play it through again and I'm going to tell you the answers. Okay? So remember, we're shouting at the screen when this is happening, guys, as if you were in the same room as me. Here we go. So, first one, breaking the piggy bank. Is that a physical change or a chemical reaction? Fireworks. Physical change or chemical reaction? Remember those clues. What are we looking for in a chemical reaction? What are we looking for in a physical change? Okay, Mentos and Coke. Okay, is that a physical change or a chemical reaction that you're seeing there? It's a mess, I know that. Cutting somebody's hair, is that a physical change or a chemical reaction? What will happen in a few months? Okay, this is a lump of potassium being thrown into some water. So what do you think is going on there? Is that a chemical reaction or a physical change? Ice melting, physical change or chemical reaction? Okay, this is when you add universal indicator to different chemicals, it changes colour. So is that a physical change or a chemical reaction? This one's a little bit tricky. Adding sugar to tea or to coffee. Is that a physical change or a chemical reaction? Oh, so this is blacksmith. So he's basically heated up that metal and now he's beating it with a hammer to change its shape. So is that a physical change or a chemical reaction on there? Right, so I'm going to scoot on back now, guys. How did you go on there? Let's have a look and see. So this, physical change or chemical reaction? This is a physical change. We can stick that piggy back together again. Fireworks, there's heat being given off, there's colour being given off, there's explosions, there's gas being given off. Those are chemical reactions. Some of the best chemical reactions there are. Mentos, look at that. As that's taking off there, it's taking off there because of all the gas that's being produced. So we have bubbles galore there. So that is a chemical reaction. Cutting hair, physical change. In a few months' time, it will be exactly the same again, okay? It's not changing. This is a chemical reaction. It's quite a dangerous chemical reaction. There's gas being produced. There's lots of heat being produced. It's actually changing colour. So yeah, we definitely have a chemical reaction going on there. Ice melting, remember that's a physical change because when that ice melts, if it gets really cold, it's going to freeze again. Changing colour, remember colour change is a really clear sign of a chemical reaction. So that is definitely a chemical reaction. And finally, dissolving sugar in tea or coffee. This is slightly tricky, this one, but it is actually a physical change because when something dissolves, you can get it out again. If you heat that tea up and so the tea all evaporates off, you will be left with the sugar. So that's a physical change. And finally, if that blacksmith sticks that bit of metal back in the fire and heats it up again, he will be able to turn it back to the shape it was before. So it's a physical change. There's no chemical reaction happening there. It's a physical change. How did you do, guys? All right. Okay, your task basically is to decide whether things are chemical changes or physical reactions. So just exactly what we've been doing on that video along with me, but you're going to do it on your own in the task. Okay, good luck, and I'll see you next lesson, guys. Or I won't see you. You'll hear me next lesson, guys. Okay, bye.